Hi there, hey there, ho there.
Hey,
Hey, hey.
How goes it, everybody? Thanks for joining us today. Another Threat Thursday Live about to happen. So I think this is actually our last one for 2025, right? Yeah, we made it.
We
Almost,
did it.
almost there. We're kind of stuck in that time in between, though. Thanksgiving and Christmas and New Year's, where time doesn't actually exist or matter, and days just blend.
it's like you're at an airport all the
Yeah.
time. Time
Right?
doesn't matter.
But we're getting there. We're getting through it. Hey, thanks for joining us, Joel. So today we are talking about DeedRAT. This one's pretty interesting. Something we put together a little bit ago. We figured we'd show it off to you guys. For some reason, this has kind of just been the week of talking about China for us. Did a workshop yesterday talking about Salt Typhoon, and just so happens that DeedRAT corresponds direct or coincides directly with that. DeedRAT itself has been seen over the last 2 years being utilized in Salt Typhoon's initial access vectors and infection chains. So it's a kind of cool bit of a tie-in. Long story short, they land, get their normal like initial hooks in, web shell, something like that. They pass in another back or a malware variant called Zingdor. It'll do some stuff, and then from there they'll schedule task, release DeedRAT. So they're pushing that in, and then they're using a behavior called DLL sideloading, which Jared's going to talk about here in a bit and show you guys how that's working, to actually get the kickoff. From there, they'll do a bit more, and then maybe pass in a Cobalt Strike beacon, continue on access and operations, and overall having threat actor fun. Some of like the cool kind of highlights here with this is it's got plenty baked in functionality already, and they're continuing to improve it. We're seeing it as new reports come out. They're adding new features and functionality into this rat. So it's still growing. It's still being used, and all in all, it's out there and pretty dangerous for what it's doing. It's very useful from their perspective. One thing of note, when they're pulling this in, they're utilizing just a simple curl cradle. So that could be an area to kind of pay attention to and look at if you don't typically see that. And then overall, the DLL sideloading piece is super cool to see. I'm actually excited to see Jared talk about it with you guys. But what's cool is where they're targeting. Typically, they're targeting legitimate like antivirus solutions like Norton and other things, and using those applications, those trusted apps, to sideload this DLL in. So all in all, it makes for a pretty cool infection chain, and I'm excited to see Jared show it off to you guys. So with that, Jared, I will let you take it away. Let's show them some
Yeah.
stuff.
Yeah, thanks for the intro, Trey. So, like Trey said, the DeedRAT is often deployed through DLL sideloading. And I'm sure a lot of people here saw that in the news recently with Notepad++ being vulnerable to DLL sideloading. So a legitimate installation of Notepad++ could be used to load malicious DLLs. And this builds off of that same philosophy. So what we did is we went ahead and we built a binary that emulates kind of a system diagnostic tool. And in the background, it actually loads in the DLL that deploys our persistence mechanisms and is the DLL that would deploy the rat. So I'll go through and walk kind of through what we do in this threat here. First off, what we do is we bring in a zip called diagnostic.zip. What we'll usually see in the reports is, for example, if there isn't something they can sideload natively, they can just bring in a PE, a portable executable that's vulnerable and can load it just through the application. So we bring that in, we expand the archive into program data, and then we run this system diagnostic.exe. And basically what this is doing is it is going to abuse the load order of DLLs. So unless it is explicitly configured in the code, it's pretty easy to just simply put a DLL in the same folder as the executable, and it will search in its local folder first before going into system32 and finding the DLLs there. And that's how this one loads this version.dll. And version.dll is something that is a built-in Windows DLL. It is usually legitimate. And this one, just based off of the name, will be loaded. So basically what it does is it goes in through the DLL main entry point and creates a thread and sets a run key persistence in HKCU, and then also creates a service backdoor. This one also simulates C2 beaconing, since we've seen them drop things like Cobalt Strike beacons. It beacons over HTTPS to a service called httpbin.org. And let me go ahead and show here. So what this is showing is while system diagnostic is running, if you use the get process PowerShell commandlet, you will actually see there's this system diagnostic.exe running. And you'll notice all of these DLLs are here in system 32, except this version.dll, which is in program data diagnostic. So this is what you'll see when a DLL is possibly being sideloaded. It looks like it is coming from a completely different location from the rest of them. Pardon me. And then up next, it also sets this run key in current users, excuse me, right here. And as we go over, you'll see program data system diagnostic.exe. And here's what it looks like in the services list right here. You see the path to the executable, see the name, system diagnostic monitor service. And then after that, what this does is it does a short collection, domain enumeration, and exfiltration. So it runs some simple commands like net user and local group administrators, looks for the domain admins, and then just finds some files off of the extension, and then it will compress and exfiltrate them. What we also did is we wanted to bake in, this is a known domain that they had used in the past. So this also bakes in a check out to that to see if your traffic out there would be allowed or denied, which is always a good thing to check based off of the IOCs in these articles. And then after that, it just cleans up. So that's kind of an overview of how it works and a little bit on how it actually sideloads the DLL. So with that, I think I can pass it over to Tyler to show you how to detect it.
Yeah, before we let Tyler jump into the cool sneaky stuff and finding it, I just wanted to take a quick sec to mention those IOC checks again. When we run these tests, we are basically here doing like a real quick benign, hey, is this domain, is this IP reachable from within your organization? If no, cool, your tools are updating properly, IOC lists match, they're doing what they're supposed to do. If yes, you might need to do some updates and check your allow lists and block lists. What's cool about that check and about our test is it is modular. You have the ability to go in and edit these however you want. So if you wanted to update this and add some of the more recent IOC checks that line up with DeedRAT, but also with Salt Typhoon, for example, you could copy that line within our campaigns and add a bunch of those in and do a real quick IOC check to validate you're blocking all that known bad C2 infrastructure. I just figured I would mention that real quick because we haven't talked about them in a while. So let's give it to Tyler now.
Booyah. All righty. Excuse me. So yeah, just kind of starting off the same way that we always do in these, and that's looking for that PowerShell or command line activity that's being executed outside of some standard directories, right? This is one we talk about every Threat Thursday we have, because I still think that it's maybe not the most important one, but it is really just a great tipping off point to finding some malicious behavior, some adversarial behavior. So here we see the parent image is running our very benign TT Live DeedRAT Scythe client 64.exe. So nothing to see there, but that obviously could be called anything. But the main point of this one is to monitor, again, that directory that it's running out of. Your programs that call PowerShell or call command prompt or things like that should be coming from like a known good installation location, like program files x86, system 32, things like that. Things running out of downloads temp, public, the same one, or even program data, as we kind of saw Jared alluding to when he was going over the threat. Things running out of these non-standard directories should draw your attention. As we see here, we can see some of that enumeration Jared was talking about, the expansion of the archive. We see some other IOCs we could probably take a look at, like this program data diagnostic folder. That's pretty strange. And then someone manually running CMD to then call that system diagnostic.exe. So just from this kind of initial query that we have up here at the top, there's plenty to go off of here to then further investigate, even if we didn't have a bunch of other logs. Just again, like this one, someone explicitly calling CMD to run an executable should be abnormal, especially when it's originally started from a parent directory of downloads temp public, something like that. And then next up into some other ones, we have the Windows key registry modifications. Specifically, this is looking for changes in the run key. So this behavior we saw, Jared was talking about some of the actions after that DLL was loaded, after that malicious DLL was sideloaded, and that's what we're seeing here. An interesting piece is that the image of the DLL, or the DLL as the parent or process image or process that's running, is not going to show up here, because while the DLL is the one that is handling all of this kind of malicious activity, it doesn't show as that. It shows as the actual image or the process of systemdiagnostic.exe doing it, which I think is interesting, because you're not going to see something like version.dll that is then creating these files and doing these things. It's going to be that process that it was loaded into, or that image that it was loaded into. So here we see that the image of systemdiagnostic.exe created some files or modified the registry. You can see that they modified the current version run to then have it start, or it modified the current version run with this system diagnostic service key creation, which then in the details is what it is actually going to run. So it created this this value and then told it to run that systemdiagnostic.exe. It's also a pretty good check, again, to always monitor the run keys, right? That's like threat emulation 101, bad guy 101 is, get in the run keys, set that persistence, so upon a reboot or something like that, we're going to kick off that that malicious activity, probably get a callback, something like that. Obviously, for a RAT, for a remote access Trojan, you're going to want to have that continual callbacks, and the run key is a great way to do it. So you definitely want to monitor it. Any changes or updates to the run key, you should probably get an alert, even if it's just a number that like it's gone up or it's gone down, that it's been modified, something to kind of tip you off. And then you want to look at the details, because that's the executable it's going to run. So this is calling for system diagnostic exe to run out of program data. That's probably pretty anomalous. It's not quite as anomalous or a tip off of if it was running out of temp or something like that. But again, something running outside of that program files, outside of system32, should draw your attention and should maybe not be a full-fledged investigation, but should warrant maybe a closer look at it. And then next up, we're looking just for file creations of DLLs. Excuse me. So in this one, we're just looking at the file creation of version.dll that was downloaded by our implant and placed inside of this diagnostic directory. Again, program data, probably something to take a look at. DLLs being pulled down with really nothing else happening around it, as well as far as like new programs being installed or something like that. It's probably pretty strange, and people just downloading DLLs is weird. That's not really something that typically happens. Most things now, as long as you have internet access, are plug and play. So as soon as you plug it in, it's going to automatically pull all of these down. So it coming from PowerShell and not maybe what the actual process or image is supposed to be, like the system diagnostic.exe. That's pretty strange, right? That's something that's a little abnormal. Also, you could see that it was made on a Mac OS box. When you archive a folder on Mac OS, it leaves this little trail behind it that would look hidden if you look at it. That's what these double underscores are. But in the logs, we can pretty clearly see that. So someone creating a version.dll on a Mac OS machine, which is then ingress tool transferred or downloaded via PowerShell and written to this program data diagnostic directory, is I would think pretty strange, something to definitely take a look at. And over on the right, what I was hoping to show with this one, this image is loaded, which is also what the DLL is called, or what the DLL is referred to in this field value. The image loaded by image, I was hoping to see the version.dll actually being loaded into the system diagnostic binary. However, as you can see, that's not what we got out of it. So I'll just quickly talk about what we do have, and then maybe why we don't have the version.dll in there. So in here, we see that PowerShell is the image or the process, and it loaded this system management automation.dll. If you guys have been on any of these Threat Thursdays we've had before, you probably heard us talk about the system management automation DLL. That essentially allows you to run unmanaged PowerShell. So we have an upshell module in Scythe. So I think PowerPick is a pretty common one that people use. There might be some other ones that Trey or Jared know of, but it essentially allows you to run PowerShell without calling PowerShell.exe directly. So anytime you see system management automation.dll being ran, I probably should tip you off that something anomalous, at least something different is happening. Someone's trying to call PowerShell and run it without actually running PowerShell.exe, because then it makes the logging a little bit different. So yeah, definitely looking for the system management automation DLL to see if maybe someone's running PowerShell in memory or something like that. Anyway, why we don't see the version.dll being loaded into this diagnostic file is because in our lab we run sysmon and just like typical security logging, and so our sysmon configuration was not updated to include I think the directory that version.dll was loaded into. So kind of a little caveat of this is how we're always talking about like purple teaming, and the time to find out things is now in a test environment and not when it's happening in real life. So from doing this test, we're able to identify a visibility gap that we have inside of our lab environment, which we can now go into and fix, right? We still have plenty of indicators here of some malicious activity happening, or not malicious, some anomalous activity happening, possibly malicious activity happening. We were able to pull the version.dll from our other query of it being written to it. So we have something to go off of, as well as we have, we do know that the binary we want to take a look at is the systemdiagnostic.exe. So in the same way that Jared showed in the screenshot from our write-up of going onto the host machine, doing maybe some more forensics on it, of just pulling the process of systemdiagnostic.exe and then having PowerShell show you all of the modules that were loaded. Sometimes you have to go a little past what you have in the seam and kind of get more into a forensic type space where you're looking on disk, running commands on disk, not going to the machine and running commands, but through whatever EDR you have, whatever live kind of triage interaction they have inside of your EDR is sometimes what you have to do to kind of get down to the bottom of exactly what is happening. But from our seam data and from the logs that we collected, you at least have a little bit to go off of. Like I said, looking at this version.dll in this directory, looking at that system diagnostic binary being ran is something you can at least start your forensic hunt on. And so it at least leads you to the right place. And then next up, we have a service creation. So this again was made by the DLL that's being loaded. But what we see is a little bit different. This is a state-based detection. So we're not looking off of the command line arguments that were being ran or any keyword searches or anything like that. What we're looking for is for new files or for registry modifications inside of this system, not Hive. I always forget what the registry values are. But inside of this registry value, inside of services, when a new service is created, regardless of how it's created, command line argument, you drop something in the directory, a program installs it, whatever it is, however a service is made, it has to be written inside of this services, not directory. I'm just going to call it directory. You guys know what I'm talking about. But it will write the service to this location. It has to exist there. So in this, we see that services.exe is writing to this registry file, to this registry value, and giving it the details, aka telling it what to run of the system diagnostic.exe. So this is also a pretty good tip off that we didn't see in our hunt like any command line arguments which tell it to set persistence, because we know it was run through that DLL. It's probably in memory. There's no logging of it, but because we are monitoring our registry values and we see that it's coming from services.exe, we know that something is creating this service. And then looking at the details, the system diagnostic we know is anomalous, probably malicious, but you need a little more investigation to kind of determine that. And then it again, running out of a non-standard directory is something you should take a look at. This details value or this details field really can provide quite a bit of value, especially if you see the details like explicitly calling cmd/c or PowerShell or something like that. Just kind of doing a stats values or stats count on the details inside of your services registry location could probably give you some insight into some anomalous activity. And then the last one up, like to include, this isn't a Sigma rule or anything, it's like kind of a monitoring location is the network connections and the DNS requests made by different images. So this isn't specifying any images. This is just everything on the box in the last like 4 hours or so. So we see up top is the, up top we have an unknown process that's reaching out to that machine on the top is our domain controller, our training instance, and then the Nextron systems, which is the Sigma HQ's or Aurora, which is basically like you can load Sigma rules into it and it'll alert you if those rules hit on it. By an unknown process, which is kind of strange. I'd probably do a little more investigation into that and see exactly what that is. And we see Chrome is running WPAD. This is not malicious. This is something totally normal that Chrome does. It's a check that it does for like internet connectivity or something like that, I think. So nothing really to see there. The Scythe agent, that's a little bit of inside baseball, right? Our agent we have on the box is reaching out to our training instance where we deploy all these from. So nothing really too crazy in the top three. But in the bottom half, we start seeing some more interesting stuff like that systemdiagnostic.exe reaching out to the http-bin.org, as well as some EC2 instances. So we can see here that it reaching out to http-bin.org, something Jared was talking about, is kind of a built-in indicator of DeedRAT itself reaching out to these malicious or anomalous sites to then check if it has internet connectivity, things like that. And then the last one is running the actual implant itself, which we see is reaching out to that Lucky Bear 669 that Jared was talking about. Again, you see an image reaching out to these kind of strange sites, but the sites aren't really what's important, because those can be quickly modified and changed. Like Trey said, your EDRs and your kind of edge devices, firewalls, things like that should be updating these kind of low-hanging IOCs automatically. And they could be changed so easily that it's not really great to focus too much on the actual query or the query name, the DNS query, or the destination host name. What really will give you a higher fidelity detection is these images, right? Something from downloads reaching out to the internet, the systemdiagnostic.exe reaching out to the internet, curl reaching out to the internet, PowerShell reaching out to the internet, SVC host. This is our internal host, so that could be nothing. But if you see SVC host reaching out to the internet, that could be something you want to take a look at as well. So yeah, on the last one, definitely more. Oh, yeah, Trey.
Yeah, that's actually a good example when you mentioned curl there, Tyler, because that's a lot of how they were doing this infection chain, is pulling in the next stage's rat via a curl command or a little cradle. So that's an easy check. Looking for the IOCs themselves, maybe not so much, but seeing curl being ran by John in HR who literally doesn't even know how to open command line, it's a little suspicious, right?
Exactly. Seeing those again, it's like the more behavioral analytics, but looking at the images is really going to give you a much higher fidelity detection than, again, like we're saying, looking at just what domains or what DNS requests are going out, because those can be changed, I mean, with really no effort, right? That's why it's at the bottom of the pyramid. Yeah, that is what I have for the detections and things like that. I think I talked for a little bit longer than I had meant to. But yeah, back over to you, Trey. You're on mute. Got him.
Has to happen at least once every time.
Got him.
But cool. I mean, yeah, I like seeing the detections and going through that. So it's always cool that we run over a little bit. That's the real helpful stuff for people, right? So I think that about wraps us up for today. That was our last TT Live of 2025. So we do have more starting up in 2026. We're going to take a little break. And I want to say it is January 8th is our first one back. We're going to talk about Akira ransomware with you guys for a little bit. So as always, come hang out with us again. If you'd like to see these or attend a workshop, come subscribe. You can find us on scythe.io at our events page. And we will talk to you all soon. Happy holidays, everybody.
Happy holidays, everybody.
Happy holidays.